which is, what did you say, Steve? That's hand-operated position, the pump runs. In the auto position, it only works when the liquid level changes. In this case, it happens to be a sump pump that as it comes up, it closes contacts, turn on the motor, and then suck out the water. In the manual position, I'm taking line 1 directly to the coil. Bingo, energize the coil, close the main contacts, that motor is running. J, okay? If I go to K, well, nothing's going to happen now. It's not going to run. It's in the off position. If the float switch closes contacts, it's totally irrelevant here because I'm not going to get voltage to this side of the coil. Therefore, that motor is not running, right?
Right.
In the automatic mode. In the automatic mode, I go line 1 through the float switch. I energize the coil. I don't have holding contacts in this example because I don't need holding contacts because as long as that float switch is up, those contacts are closed, that motor, the coil is energized, main contacts are closed. As soon as the water level goes down, and then we had a differential, I think you guys told me about, right? There's a differential. How far does it go down? It'd go down a teaspoon and then go back up and down. Then it automatically opens up the circuit. So under the L position, it's in the automatic setting, and the J position was in the manual or hand position, and the K position was off. Okay, let's understand truth tables. So, in J position, A1 contacts are closed. K position, nothing is closed. L position, A2 contacts are closed. I got it. Variations for 2-position selector switches. All right, here we go. Another variation of 2-position selector switch is how the contacts represented in a control circuit. We have a single break symbol. We talked about that yesterday, Eric. You explained to me why maybe you'd have a single break versus a double break. And you were saying that, well, let's review this. What were the reasons why would I go with a single break selector switch versus a double break selector switch? I mean, aren't selector switches pretty much double break though? Would that be the general case? You go to J or K?
Well, they're really used for two different purposes. I mean, that a lot of the selector switches that switch power, like limit switches that actually switch power, they're going to be heavier duty, and a lot of those are double break. Another, Dan brought
Hold on, slow it down. Heavier duty would be more than likely a greater ampere rating because they're distributing that energy and making and breaking over 2 contacts versus a single contact. So they might not be, okay, I got it.
But then, like I say, Dan brings up a good point in that if you have a double break switch, you can control 2 circuits. So you have one perspective, which is power handling.
Hold on 1 second. Right now with a single break, this is the only option I could possibly physically have, right, Dennis? I mean, this contact closes if you turn it to the left. This contact goes down to reverse, turn it to the right. Or a 3-way switch, you go up, you go down. I mean, that's it. If you come down here now, you could have the break across the top. Okay, turn it to the left. And then if you go down the bottom, you'd have the contacts close across the top going to the left. And then the contacts in the bottom are close to the right. But you have the option to disconnect this jumper if you want to. And you can say, okay, well, this stays in here, disconnect the jumper, and have some other circuit that could be used making and breaking with this portion here. Is that what we're talking about here?
Yes.
Yeah, I think what you see a lot of times, or what I see a lot of times, is a lot of these switches are double break, and a lot of the other electronic components are single break. Like relays tend to be single break, and a lot of selector switches tend to be double break.
Okay. We're going to go to this single break graphic. Let's just follow this here. All right, just a little practice here. Okay, we start. We energize power, stops on one side. We have line 2 going on the other side of the forward coil. Okay, here's a forward coil and a reversing coil, all right? If we take the selector switch, we put it to forward. When you press the start button, we're going to energize the forward coil, which will close the F3 contact. It will open the F7 contact. And we will have voltage that will travel and be held through to the F coil. The F contacts in the motor will be closed, and the motor will be running in the forward position. And because of the selector switch, you can't go reverse. If you want to go to reverse, however, you would switch the selector switch to the other position. It makes the contact on the reverse. And you would, oh, wait a minute now. You'd be able to go from forward. No. As soon as you open a contact to go down, you're de-energizing the F coil. You're opening up this F contact. As soon as you get down to the reversing position, that motor has stopped. Right. And we're talking, it stopped. There's time. You'd have to press the start button to get voltage across the start button to energize the R coil, to close, to keep that R contact open, and to close this R contact to interlock that. Right?
Right.
I got that one. All right, double. All right, what's the big deal, double? Okay, we have power coming in on one side. We have voltage on the other side. I press the start button while I'm in the top position, which is the forward position. I energize the coil. I close the F contact here that interlocks that coil. I open this contact that was closed on the de-energized state. I open that contact, so it doesn't really matter. I couldn't go anyhow in that direction. So that really serves no purpose at all there. If I push it down to reverse, when I move it down to reverse, I de-energize this coil. I open up the F contact. I go into the reverse position. I have to press the start button to energize the reversing coil to close the reversing contact so that we can interlock or latch that reversing coil. And so it's the same, we're getting the same function, it's just that we're using a different selector switch, single versus a double break. Okay, chapter 2 is in the bag. Move into chapter 3. Many applications require motors to run both forward and backwards. And in this chapter, we're going to cover the concepts, components, and schematics necessary to achieve those goals, and that is to get the motors to reverse. Okay, starting at Unit 11, we're going to deal with reversing controls for three-phase motors. Let's just understand how three-phase motors operate. Line 1, line 2, and line 3. If we connect to T1, T2, and T3, then the motor goes in a particular direction. To reverse a three-phase motor, this is covered in a theory course, all you have to do is reverse any two leads. So if line 1 was connected to T1, but we now connect line 1 to T3, and if line 3 was connected to T3, but we reconnect it now to T1, and somehow achieve the reversing of two conductors, this motor will now run in reverse. But I have to ask you guys a question. I haven't done a whole lot of three-phase, obviously, in a long time, so I'm not an electrician anymore. I guess you are always an electrician. When you hook up a motor, does it always run the right direction? I mean, let's just start from the beginning. I mean, you got the thing hooked up, you put the three-phase conductors. Is there a direction that you really care anyhow? I mean, do you really care which way the motor starts and runs to get it reverse the other direction?
If your line 1, line 2, and line 3 are correct.
Oh, wait, 1 second. Hey, it's black, red, blue.
Yeah.
I mean, that's correct, man. That's line 1, line 2, line 3.
Then most manufacturers will say that their motors, if you hook them up to line 1, 2, and 3.
Yeah, but how do I know what line 1, 2, and 3 is? I just put 3 wires out there, and the utility brought 3 wires, and they hooked up the 3 wires and my 3 wires. How do I know what line 1 and if the utilities give me power? How do I know what line 1 is? And Steve, you know what I'm talking about?
Yeah, Dan has the luxury of working at the same plant every day, where he knows what his system is.
All right, well, let's get you out of the picture then.
Yeah, those are their
Let's get with people who don't know.
If you're on a different job,
I go to a warehouse and I'm hooking up a motor and I
you're
just
a different
to
job
the panel.
every day. Yeah, you don't know.
Do I know?
You know, because there's a meter that will tell you.
Really?
You can buy a phase,
okay. You're saying
phase orientation meter.
Okay, you're
Rotation
saying
meter.
you will know because you can get a little tiny thing that you hook up to line 1, 2, and 3. So what you need to do is if you have multiple three-phase motor in a facility, you need to make sure that the service conductors that you know, they're line 1, 2, and 3. Am I right about that?
Yeah.
So that everything else you connect to, if you use your color code properly, let's say black, red, blue, if that's the color you're using, then if you make sure you run line 1, line 2, line 3 to every single motor, connect T1, T2, T3, then they're all going to run the right direction the first time. But if you go to a warehouse, you got a three-phase motor comes in there, you run 3 conductors out there, you hop on a three-phase breaker, you turn the thing on, and it's not running in the right direction. Well, I hooked up to line 1, line 2, line 3, but it really isn't line 1, line 2, line 3. You then have to then reverse those to get them to go in the forward direction before we start worrying about reversing it.
And that's why you never couple it to the driven equipment until you've tried that out to see which way it's going to turn.
Really? Okay, so you don't want the equipment already connected before you start the motor
Check your rotation.
because it could be bad news.
It could be.
So now, how much does it I guess it doesn't cost that much to buy a three-phase rotation meter, does it?
No.
What, $100, $200?
They're a couple $100.
Couple $100? But if you're going to be hooking up a motor, then, and if you're saying, well, but if you decouple it, right?
Yeah.
First of all, then you can hook the thing, all right, and turn the 2 leads, and now the motor's running in the right direction before we start reversing it.
That's
Eric?
a good.
Go ahead, Dan.
That's a good chance to use your jog push button because
Yeah.
if you hook it up,
You got a selector switch.
You got the
Put that
selector
baby
switch.
into jog.
put it in the jog, and
And
then
just
you
tap
can
it.
just bump it and see
Yeah.
which way it goes.
How do you know which way it's supposed? How? I'm like, I don't know. Is it going forward or backward? How do I know which way it's supposed to go?
Most devices that you hook to are either going to be a conveyor or will have an arrow.
So if the conveyor is going the
Like
other
if it's-
direction,
Like if it's a pump,
Yeah.
it'll have an arrow on it. Air compressors normally have an
Yeah.
arrow on them.
so is there an arrow on a motor that indicates which way the rotation is supposed to
Not
go?
on the motor, on the
No, not
equipment.
on the motor, but on the equipment that you're coupled to.
Hey, let me ask you a question. Is there supposed, if I go to, is there a direction that a motor turns? Do they go clockwise? Is that considered forward?
Well, that's an excellent question.
I thought so.
There are NEMA frame motors have got a bidirectional fan because motors have fans for cooling. And so if you have a bidirectional fan, then you can run the motor either direction. But on some of your larger motors, the fan is actually a unidirectional fan, and if you run it in the reverse direction, you would have to put a different fan.
But do motors, is there a standard direction that a motor is counterclockwise considered a forward direction?
Yes.
Because if that were the case, I don't need to have any meters. I go to a jog button. You know what I mean? I can just simply, okay, it's going counterclockwise. Okay, guess what? It's not going forward. So forward would be clockwise.
And it's from the front of the motor, which is the end opposite the shaft.
1 second. Which way am I looking at it?
Opposite the shaft.
I don't know what that means.
So wherever the shaft comes out of the motor, you're going to look at the opposite end.
So
For your
I'm
rotation.
standing here and the shaft is over there. I'm behind. I'm by here where the connections are being made to the motor.
Yeah.
And that's the direction that it goes. It rotates.
Counterclockwise
If you connect
It rotates
line one,
counterclockwise
is
if I'm
what they
behind.
is what they call standard rotation.
But if I go on the other side, I'm looking at the motor and I'm seeing the shaft coming to me. It goes which way?
Clockwise.
That's the side I want to go to. Okay, got it. All right. Hey, this is free. What are you planning on covering this in the DVD? So you guys got that one.
Can I just bring up one more thing?
Okay, fine.
Okay, thank you, Mike. If you have a facility that has several panels in it, then
Yeah.
your panels also have rotations.
What does that
So,
mean?
well, let's say your service has a L1, L2, L3 in sequence.
Yeah.
Okay. Well, if you connect up 3 wires to a sub panel, and those 3 wires are swapped,
Oh,
then you will have
Yeah.
a separate rotation. You might have a clockwise rotation on your bus of your service panel, but you might have a counterclockwise
so you're gonna have to change the
rotation.
2 wires. So you really need to make sure if you have Dan, you have a large facility. All your panels and all your phases are all line 1, line 2, and line 3. And you know when you connect the line 1, line 2, and line 3 to a motor, you know that the panel rotation, phase rotation is correct all the way down the line. True?
no.
Okay. But if it were true, then you would need a phase rotation meter and you could be okay. All right, let's go on. All right, you can see that, you know what? We better make sure we get the motor running in the right direction before we start so you don't screw everything up. And then we can start worrying about reversing this baby. All right, assuming we got the right rotation, line 1, line 2, line 3, and if I close the forward contacts, line 1 goes to T1, line 2 goes to T2, line 3 goes to T3, motor goes in, don't tell me, clockwise rotation as I'm looking at the shaft. We can maybe put like a little round button there. All right, got that taken care of. Now, if I want to reverse the motor, I need to reverse any 2 leads. So line 1 now comes over. I go to the reversing contacts. It now causes that voltage to continue to T3. Line 2 goes to the reversing contact, which goes to T2. Didn't change. Line 3 goes to reversing contact, goes over to T1. I now connect line 1 to T3, line 2 to T2, line 3 to T1. Now we're going to have rotation opposite of the original rotation. Got it. Interlocking devices. Interlocking reversing controls prevent the forward and reversing contacts from being energized at the same time. A good plan. So, this is a mechanical interlock. We're not going to spend too much time here. But the way this interlock works is that if you press the forward button, then mechanically it disables the reversing contacts from physically being able to be closed. Is that right, guys?
Yes.
It's done mechanically. It's not done electrical. And if I'm going in reverse, well, then you can't press the forward button while you're going in reverse, because if you press the forward button, then the reverse button isn't going to work. Or it's going to take you out of reverse and it's going to go in a different. You can't have them all close at the same time. We don't want to go line 1 to T1 and then have line 3 go to T1 and then have them both close at all 6 contacts closing. So there's a mechanical connection to prevent them from all closing.
I think you could switch, but in
You
switching,
could switch.
it's going to remove. It's going to de-energize the opposite direction.
Right. So you're either going forward or you're going reverse, or you're going forward, reverse. But you can't close all 6 contacts because 3 of them will close and then mechanically disables the other 3, or the 3 here close and mechanically disables the other 3 contacts. Do we have a mechanical contactor there?
One right here,
Yeah.
where it shows it right here.
Right there in the center of that particular one, there is a mechanical interlock physically right there. Okay, let's go on. Most reversing magnetic starters contain factory installed mechanical interlocks between the forward and reverse, and that's what you just showed there, Dennis. The interlock device physically locks out one contactor at the beginning of the start cycle for the other contactor. And that was that's a picture of the mechanical interlock, right? That's the dotted lines.
Yeah, here we have gone to electrically operated relays, though, and the picture we had before was a mechanically operated.
Oh, you're right. This
have
one
switched a little
was
bit.
a physical,
That was totally
no coils,
mechanical.
no electrical.
Yeah.
This one is going to be an electrical that when, okay, let's follow this one here. Let's see if we have it. There we go. We press the forward button. Energize the forward coil. Closes the F contacts, which keeps the F coil energized. The F contacts are all closed. Motor runs forward. At the same time, the F coil, that's it. And because this coil is energized, it mechanically disables the reversing coil. Is that what it's doing? It prevents it from going
Yeah,
in reverse.
There's a mechanism. that
There's a
won't let
there's
them
a physical mechanism that when this coil is energized, and then it physically can't go there. Let's go to the reversing button. You press the reversing button, you energize the reversing coil, and that then closes the reversing contacts, but mechanically. Tell me, I'm confused here. Is this forward and reversing button causing a mechanical disconnection between the 2 coils? Or is
there's just a mechanical arm between them that won't let them both pull in at the same time. And one of the dangers of this circuit, where it doesn't have any electrical interlocks but just mechanical, is you can push both those buttons at the same time, and it's going to try to energize both, but it mechanically can't. So you're going to sit there and fight, and you're going to burn out one of your coils.
So they're both trying to go
Yeah.
this way, but you press them both at the same time, and now you're creating it. You got something there,
Well,
Dennis?
this one here is the electronic, and I can push this one in here and try to push this one in, but it won't go. And then release this one, push this one in, and then this one won't go.
Oh, so there's a mechanical connection that
Right.
when that coil energizes, it kind of like drives something in there that prevents the
Yeah.
other one from mechanically making it break it, because it's the contacts that
There's a lever between them.
So when you energize this coil, it's making these contacts close, but it's mechanically then like putting a shim in, preventing the other physical contacts from contacting. But as you said, Steve, if you press them both, then both coils are energized and they're both trying to close. Got it. When this type of reversing controller is used, the stop button, push button must be pushed to de-energize the contactor before the motor can be reversed, allowing the interlock lever to reset. Let's take a look at this graphic here. This is the mechanical interlock one. Here is our ladder diagram, and here's our wiring connections diagram. And I'm not going to get into all the details, but here is my forward contacts. here's my reversing contact. We already seen where line 1 goes to T1 and line 2 goes to T2 and line 3 goes to T3 if you have the forward contacts. And if you energize the reversing coil, then line 1 goes over to T3, line 3 goes over to T1, and depending upon which coil, there's now this one doesn't have, well, the mechanical interlock is shown here. Of course, it wouldn't be shown necessarily there. And we could then follow the wiring in here and house of control, say line 1 goes over to stop, but I'm not going to get into that details. You guys can take some time and kind of practice that. That's not the point we're making right now. How about we can add electrical interlocks for the magnetic reversing controls? Electrical interlocking is accomplished by wiring the auxiliary contacts of one circuit to control another circuit. All right, here we go. Okay, we have mechanical interlock so that if I energize this coil, there's something that's going to wedge that's going to prevent the R contacts from closing. We just don't see that physically now. So let me see if I have any sequencing here. I press a forward button, energize the F coil, which closes the F contact that was open. It opens the F contact that was closed, and it closes the forward contacts for that motor to operate forward. Steve?
So now I'm not going to be able to burn up my coil by pressing the reverse. I've taken that problem out.
So now, in this case here, if I'm pressing reverse, because this F contact that was closed is now open because the F coil is energized, I can't get voltage to this R coil.
Right.
In this one, if I had forward running, I could, at the same time, electrically press this button, and I could energize the coil.
Right.
It still might be running forward,
Yeah.
but it will be running forward because that was the first one we pressed. It interlocked the contacts out. It's not interlocking the coil, it's interlocking the contacts out, but this allows me to press the reversing coil at the same time the motor is running forward. If I'm running forward, then electrically we have disabled the control circuit to the reversing coil. And if I was running in reverse, the R coil opens the R contacts that were closed, closes the R contacts that were open, it latches the R coil, but if you press the forward button, you cannot energize the forward coil. Push button electrical interlock. 2 double circuit momentary contact push buttons provide the electrical interlocks in this control circuit. All right, what do we got here? All right, we have a forward button that has closed contacts and it has open contacts. And then we have a reversing button that has closed contacts and reversing button that has closed contacts and open contacts. And for a moment I was thinking, well, wait a minute, now, isn't that a selector switch? And the difference between this button and a selector switch is that we can't change this condition, can we? These contacts are closed, and these contacts are open.
Well,
and there's
only
nothing.
momentarily.
Yeah, but I'm saying we can't change this ever so that it would be where that is closed
Right.
and that was open.
Right.
Correct.
All right, so we're not going to worry about that now. All right. Here is my normally open, normally closed contacts. Okay, that's right. One is closed, one is open. Here's a symbol and a ladder diagram. Now let's see what this means. Let's go with forward. Press the forward button. Oh, when I press the forward button, I am mechanically opening up this normally closed contact that's normally closed, so that if the coil R was energized, I'm going to de-energize the R coil, and I'm going to close the contact here that will energize the F coil, which closes the F contacts. At the same time, I have the F contacts here that close, that were open, and that latches that coil, so now I'm running forward. What we have here is we have the mechanical interlock, as well as now we have the push button that will disable one versus the other. We just don't have the F, we're not using auxiliary contacts. We're on this example here, we were using auxiliary contacts, is that right? Right here?
Yes.
To disable that control circuit, where in this one, we're just using a push button. Now, when you push the forward button at the same time, it's going to open up these contacts right here and disable the reversing coil. So there's ways of being able to provide a level of protection. And this one has both of them. You have the mechanical interlock, and you say, you know what, on top of that, I don't want these guys to press both of those. We're going to go ahead and do a push-button interlock. Steve?
This one does a good job of protecting your starter so you can't energize both the forward and reverse. But the disadvantage is you can slam it right from forward into reverse just by pushing one button. And I think Dan can talk to what that does to equipment.
Hold on one second. If I press the forward button and I'm energizing the coil and I close the F contacts, that baby's running, right?
Yeah.
I could then immediately press the reversing button. Oh, no, I could press the reversing button, and immediately at that instant, I open up the voltage to that motor forward, the coil. But at the same instant, I'm also energizing the reversing contact.
Yeah.
So I'm going from forward
Slammed off.
immediately to reverse. It's like
Yeah.
driving forward and going wham into reverse.
Yeah, it's called a
Yeah, you can.
plugging
You're not going
reversal.
forward and reverse at the same time.
Right.
But I mean, you're trying to go in reverse. But what's the difference? What about the
That's
other
called
ones?
a plugging reversal when they do that.
But hold on, I want you to say that term. In this example here, even with the interlock, if I press forward, I energize the F coil, close the F contacts, I'm going forward.
Uh-huh.
If I can't press reverse.
Nothing will happen there.
Right.
I
That
have
locks
to
you
press.
out from reversing. You have to hit stop.
I have to
reverse.
press stop.
Yeah,
Then I have to. Okay, then I can press reverse.
right.
Right.
And that action of hitting the stop button is probably going to take a second or two and let that motor coast down at least a little bit.
In other words, it's not wham.
It's not a plugging reversal.
You have to press stop. But maybe you don't want a motor that goes in reverse within a certain period of time. Is that right? That's when you put some other controls, some timing that
Yeah,
won't
it's real
allow
common
you.
to put a time delay in between a forward and reverse.
Yeah.
It really saves the motors. It's really hard on them to, because as we talked about before, you have 600% current when you start a motor. Well, if it's already going the wrong direction, you're going to have somewhat a lot more than that, maybe 1,000, 1,200%.
So if you're looking to now, what you could do is put some kind of device that would measure the rotation of that motor. That once it stopped turning, right? You could have
Yes.
a two-wired limit, right? Switch.
Yes.
So okay, motor has stopped turning. Okay, now you can then go in reverse. So you can. That's where you start adding controls, as we're talking about. And that's when Steve said you become the go-to guy. You go out to this machine shop, and this guy wants this and this and this. I want to make sure you protect my motor. I don't want this motor to be able to go in reverse until after it stops. Well, then now you start designing the circuits that make it happen. All right, let's talk about combining interlock methods for a reversing starter. Reversing starters that combine all three types, mechanical, electrical, and electrical would have been what? The push button as well as the auxiliary contacts is the most common reversing starter design. All right, let's take a look at this here. All right, here's the mechanical, and Dennis, you had showed us the mechanical, the physical mechanical, and then we had gone over to where the auxiliary contacts, we're using F1 and R1. I like when we have an F1 and an R1 or F2. Those are nice. And then we have the push button that if you press the forward button, you close that one. Well, then you open up the close contacts of the forward button, which disables the reversing coil. I don't think there's a need. You guys want to go through the whole thing, or you think it's kind of straightforward? And we cover the three different ones, and people can take a look at that if you're not sure. And we're going to cover it. Here we go. Let's see. Okay, right now in the stop position, the coils are not energized. We probably shouldn't color that one side right there. But if I press forward, I energize the forward coil. I then will close the F contact, and it'll latch that coil. I'll open up the F2 contact that was closed. That will then electrically disable that R coil, and we've mechanically disabled the R coil. And by pressing the forward button, we opened up the F contact that was closed so that if somehow the R coil were energized, as a third possibility that there's no way to energize that R coil. And that was our forward button, and we kind of got that taken care of. Motor continues to run forward. That's the example we just did. Let's take a look reverse. Okay, stop it. You got to stop it first because you can't go reverse. You stop it. Now, pressing the reverse button. Open up the reversing contacts that prevents the motor from running forward. Energizing the R coil, which opens up the R2 contacts, will now for sure disables the F coil. Also, there's a mechanical interlock that disables the contacts for the F coil to close. Then we close the R1 contacts, which interlock the R coil. And then when we release the button, the R coil is energized, the F coil is contacts are disabled, the R2 contact is held open, disabling the F coil, and we're good to go. Wiring a reversing control with a selector switch. A two-position selector switch can be used with a regular start-stop push button station to control a reversing starter. All right, let's see what we got here. Two-position. Oh, I see, because we have a forward coil and we have a reversing coil. And if we go to the forward position, press the start button, energize the forward coil, close the F3 contact that was open, open the F7 contact or the F contact that was closed, so electrically disable the R coil. By F contact being closed, we probably don't need all these numbers on here. I don't think it adds any value, so we'll probably remove all those in these examples. By the F coil being contact being closed, we energize the F. We keep the F coil energized. All right, let's see what we got next. That was the start button, and what we just described. So that stays energized. Now, if we go in reverse, now guys, if we go in reverse, the moment I go to reverse, I de-energize the F coil, right? And I actually drop, then it goes into a de-energized state, doesn't it?
Right.
This graphic really is only accurate that when you go into reversing, so we need to identify that this is only going in forward after you press the start button
Right.
because we're in the forward position. And this is only energized, and we need to make sure we make that clear, that if you go into the selector switch to the reverse button, close in these contacts down here, maybe the A2 contacts here get closed, but you had to press the start button, energize the R coil, open up the R contact, disable the F coil, close the R contact here, which interlocks the R coil. I can see a selector switch. So really what I'm learning here is with all the different combinations of switches, there's lots of ways of skinning this cat. Approaching the tools that you have. Okay, I can't get this working. Hey, put a three-way switch there.
Exactly.
Hey, you know what? We could use this. Let's put a two-selector switch. So the more knowledge you have, the better you are at solving these problems.
Mike, is that you have to understand what the functions of the motor is to be and how it's to be started and stopped and what other items are in there that's going to control the motor.
And
once you understand that, then you can pretty much use anything.
And as Steve said, the more you know, the more you can help your customer. You can say, you know what, we really should put something in here to prevent the motor from this, or we really should do this, we should look for this, and we should protect this, and we can add more features. And so that's the way, as a contractor, you're a contractor, that's the way for you to upsell, but you're really taking care of the customer's needs. If they're not providing, whoever designed the system is not, or you're designing the system. Reversing controls with limit switches for three-phase motors. This unit covers the use of limit switches in conjunction with other components to control the duration and the direction of motor operation. Another variation to the standard forward and reverse control circuit is the use of limit switches to automatically stop a motor when it's reached a predetermined amount of travel or torque. Let's take a look at here. Okay, I got my ladder diagram. I got my forward buttons. I think they were two position buttons that when I press the forward button here, I'll energize the F coil. I'll disable the reversing coil, so I have protection there. I got some mechanical interlock between the contacts of the forward and reversing. I got a green light in parallel with the forward coil, and I got a red light in parallel with the reversing coil. And then we have a forward limit switch that we can place in this portion of the circuit, and we have a reversing limit switch that can be placed between this portion of the circuit. Let's take a look at that. If we put the limit switch between 3 and 6 for forward limit switch, and a limit switch between 5 and 7, all right, stop button is normally closed, reversing button, this portion is closed, this portion is open, this forward button is open, And if I press the forward button, and the limit switch is closed, the forward limit switch is closed, and the forward coil will get energized. The green light will illuminate. The F contact that was open will close. This will interlock the F coil. The F contacts to the three-phase motor closes. The F2 contact opens, which provides protection against going in reverse. We have mechanical interlock, so the coil cannot close the contact simultaneously. We have this reverse button that's open, so therefore you can't energize. We have all our what? We have our button interlock, we have the electrical interlock, and we have the mechanical interlock that we talked previously. So if you press the forward button, motor's running forward. Let's go backward. In order for this to go reverse, if I press the reverse button, that will then de-energize the F coil, open up the F1 contact, close the F2 contact, but I can just about have this baby go immediately in reverse, can't I?
There's going to be a short
But,
break, but it will.
But
Yes.
yeah, for all practical purposes, this thing, it will. Oh, we didn't talk about Dan. I wanted your feedback on that. Have you guys had any experience with the motor running in one direction and then immediately, that it goes in the opposite direction because of?
That's
like,
on single phase motors. If you reverse a single phase motor before the centrifugal switch drops out. And we'll probably be getting into that later in this
Okay.
chapter.
All right, but what happens physically? Anybody know what happens when you take this motor? It's running in one direction. You
Oh,
immediately.
You can tear them up, and depending on what kind of equipment you're running too.
I understand why. Why, if it's electrical, why are you? How can you tear up a motor? Is it pressure torquing?
the
It's
torque,
just the
yeah.
energy. You have all this kinetic energy going one direction. Now electrically, you're twisting one while it's trying to twist the other. Is that
Yeah.
what's going on?
Yeah, it's not only locked rotor, but you're going the other direction. So you reverse, you're more current than locked rotor.
Oh, is that right?
Good example is a hand drill that's forward reversing. So you got it forward and you let your finger off the trigger and all of a sudden you throw it into reverse and hit it again. And I mean that torque, it just torques your hand back from it all of a sudden reversing. So you could just picture that on like a 25 or a 550 horsepower motor and see, what
gotcha.
it's going to do.
Depends on the kind of equipment too. If you're driving a conveyor belt full of coal in one direction, once you slam it in reverse, all your inertia from all that weight, you're going to be breaking up all kinds of the equipment too, trying to reverse it.
Oh, as all this equipment that's being turned by the motor, which driving this inertia, all that equipment is attempting to go in the opposite direction
Yeah.
while we're having all that mass going in one direction. So now you wipe out all this mechanical portion.
Yeah.
All right, excellent point. Again, if that's what you want, then looking at the circuit that we have here, this is not the best circuit. You need to put some kind of slow it down so you can't go immediately into reverse. All right, let's go on. Reversing controls, limit switches for automatic forward and reverse. When limit switches are used for automatic forward and reverse circuits on machinery, double circuit limit switches are generally used. All right, here's a double circuit limit switch. Now, this is not a selector switch. I don't have choices to change here. This is just the way it works. You have a set of normally closed, set of normally open contacts. Okay. So if you move the lever, okay, that's what it looks. You move the lever, okay, if that's normal position, that'll be closed, and that'll be open. Then you can turn it, that would open it, and that would close it. All right, let's take a look at this limit switch here. Okay, so this is closed, and this one would be open. If I press the start button, I energize the F coil, close the F1 contact, interlock the F coil, open the F2 contact, prevent this from going in reverse. This thing is going forward. When it gets to a certain predetermined point, this would rise, this would open, de-energize the F coil, open up the F1 contact, close the F2 contact. All of a sudden, when it gets to the end, oh no, as soon as it opened, it stopped the whole process, right? It
Well, that would-
stops.
That one on the bottom would close and that would energize your reverse.
Well, no, because when this open and then this goes to close, isn't there going to be a delay? So therefore, this coil will drop out.
Your forward will drop out and your reverse will pick up.
I thought I'd have to hit the end, it would stop, and I'd have to press the start button. Are these gonna, is this gonna make before this opens? Or are they gonna
No.
do it at the
They're
same
gonna do it at
time?
the same time.
So you're saying, the way this thing
No,
is shown here, this is gonna go from forward, when it gets to the end and it opens, this is gonna close, and it's not gonna,
It
It's-
has the potential, Mike.
okay.
It
it
has
has-
the potential.
That it might close and go in reverse, and it might not,
Right.
because it's a matter of timing, yes.
And that's another characteristic, not only of limit switches, but your push buttons, anything that has two contacts, is you need to know, are they a make before break or a break before make contact? Some of those are built with a differential in their switching, built
Okay.
right into them.
So, and we don't know what this is
Yeah,
gonna
we don't
be.
know what this is.
All right. All right, let's see if we can look at an application. We have a conveyor, and we have this contact right now that's closed and that's open, and then this one else, limit switch 2, this is closed and open. And when we go this direction, it changes the state of that one that was closed, and the top one was closed and the bottom one was open, that this one is open and the bottom one is closed. And let's see if we go the other direction. We go the other direction, and when it hits this point, it went from open to closed and from closed to open. All right, let's take a look at an example here. Let's assume, okay, for the class, Dan, and for everybody else in the video, that these are making at the same time, okay? Let's go with that assumption. Go ahead and make an assumption. All right, here we go. We have the stop button. I press the start button. Coil F energized, F1 contact is closed, F2 contact is open. I mechanically interlock the R coil out. I electrically interlock the R coil out with the F coil F2 contact. F1 contact is closed. We can get rid of these numbers. They don't serve any purpose for this application. And I would then have voltage traveling on here. This coil is energized. But, so we're going forward. As soon as this hits this point right here, it now opens the L2. It will open this. It will close the limit switch 2. And if it happens at the same time, then we maintain voltage to the R coil because we de-energize the F coil. We close the F2 contact. And we close the that F2 contact that was being held open. We allow that to go back to its normal state, normal close. Then the R coil is energized, which closes the R1 contact. And now we're running in reverse. Is that okay?
That's correct.
Let's go now in the reverse. Now it's running in reverse. So this thing is going back and forth. Give us an example where something would be up, back and forth, Dan.
Well, I'd give you a couple examples. One, the easiest would be like a stretch wrap machine where you've got a turntable that your pallet would be turning on, and then your stretch wrap, of course, is going to go up to a limit switch and then down to a limit switch. And however many wraps you put on it, that way it'll
Is that a
evenly be
manual thing that you
dispersed.
press it to hold it, or is that something that it could then determine? You could then put a counter, say how many times this thing is wrapping around it, and you can say 4 wraps, and that's another control. Was that right? Counter 1, 2,
Yes,
3, 4.
and you would use the limit switches to change the direction just exactly how you have it listed here.
Okay, so now we're going in reverse, and when it gets over here, okay, so now stop button. Okay, this was being closed, is what it was. Energize the R coil, but when it goes back, it opens up limit switch 1, closes limit switch 1, which then has it going, see, it's going up, and it's going forward, it's going backwards, forward, backward.
Yes, exactly.
Steve?
There's one spot in there that's a little bit difficult to visualize, and I don't know if I can help it by saying this or not, but when we first go through that and we say it's switching directions, we can get hung up thinking, well, when we go to reverse, that F2 contacts are open and they have to close. But we want to remember the LS2 contacts down there are not a momentary. They're going to remain closed as long as we're dwelling on that limit switch. If we're the end of travel, LS2 will stay closed long enough to let us make that transition from forward to
This
reverse.
isn't a momentary thing that's occurring.
Yeah.
Right.
We're talking about
As long
it
as our
hit
box, as long as our product
this.
is
Okay,
against it.
Dennis has it.
Okay, yeah.
So as soon as the product hits it, it held it. Now
holds it in
drops
its-
one out, okay, because it opened it.
Yeah.
But it closed a set of contacts, which puts the other one on.
Yeah.
So therefore, that's why it wasn't like a momentary,
Yeah.
contactor that was dropping one. It's a mechanical connection, and then all of a sudden, boom, it goes the other
Yeah,
direction.
we got to see that it stays closed long enough to let us make that transition.
That's the answer. That is perfect. Let's see what we got next here. Version controls for limit switches for garage door applications. Okay, that's kind of like makes sense here. All right, here's the control circuit, and here's the dotted line as an option that you can add to it. You get rid of the jumper between 3 and A, and you add the limit switch in between 5 and B. So 3 to A is you get rid of your jumper, you can put the limit switch, and 5 to B is where the jumper can go in for a limit switch. And so we put the jumper between 3 to A. Oh, but this doesn't have the 2 switches. This only has 1. I think I know where this is leading up to. The other one with the 2 switches was leading up to what? It gets to the end, it stops, it rotates, it comes back the other direction because there's enough of a delay, and then it goes back and forth.
Yeah.
This one is a garage door. I'm not looking for it to go up and down and up and down. I'm looking for it to go and then stop. So I'm only going to use a single contact in limit switch 1 and a single contact limit switch 2. Let's see. I want the door to go up. I press the up button, energize the up coil, close the U1 contact that was open the U2 contact that was closed, so I can then electrically interlock the down coil out, as well as the mechanical interlock between the contacts. And then the U coil is energized, close the U contacts to the motor is going up. Then if I press the down button immediately, I can't, can I? I can't, I can, yeah. You can press the down button, but you can't energize the down coil because the U coil has electrically interlocked as well as a mechanical interlock, so that's not going to happen. All right, let's look at the example here. All right, the energized state, the up coil and the down coil has the voltage that needs from line 2. We have line 1 voltage coming in here to all the switches, is to all the contacts. Press the up button, energize the up coil. We're going to then close the U1 contacts, open the U2 contacts. We're running, and that's the state right there. Closes that, opens that there. And then you release it. It will continue to run until limit switch 1 opens. There must be a travel that it's going to go. It's going to hit a limit switch, and then it's going to open. That limit switch then will stay physically open. And now, so it's open. All right, so now that U1 contact will open that was being held closed, and the U2 contact that was closed was being held open, puts us to this state right here. Now the motor has stopped. Now